Did you guys learn the law of sines in geometry? Yeah. I taught you a couple of your geometry, so hopefully, did you do the law of cosines? Anyway, the law of sines. The sine of an angle over the side across it, the sine of an angle, the side across from it, or isn't it? I'll call it y. And that also equals the side of this angle, of course it's 60 because it's a 30, 60, 90 right triangle, over the side across from it. Each one of these is just a number. Like the sine of 90 is a number, you can plug it in your calculator. As long as your calculator's in degree mode, it'll come up with an answer. On a unit circle, the sine of the number is given by the y-coordinate. And this is the 0 line on a unit circle. So 90 degrees is just this way, 90 degrees. The coordinates of this point, the x-coordinate is 0 and the y-coordinate is 1. So the sine of this angle, 90 degrees, is the y-coordinate on the unit circle. It's just 1. So this just says 1/8. And that equals the sine of 60 over x. You guys remember I talked about this a little bit. 60 degrees on a unit circle is like 30 degrees less than 90. It's like up here. And the x-coordinate is actually half of the way to 1. The x-coordinate is 1/2. And the y-coordinate is that side. Anybody remember what it is? All the coordinates on the unit circle are either the square root of 1 over 2, the square root of 2 over 2, and the square root of 3 over 2. Those are the only three numbers you have to memorize on the unit circle. There's 3 numbers. It's as easy as 1, 2, 3, right? Because everything else is the same. And 1, 2, and 3 are in order, right? If you take the square root of 1, you get 1. Take the square root of 2, you get 0.707 something. Take the square root of 3, you get 0.86 something, right? I mean, they're in order. This is just about 1 whole. This is more than a half, and this is, well, yeah, it's 1/2. So the coordinates at this point, the x-coordinate is 1/2, the y-coordinate is the square root of 3 over 2. Now you can use your calculator to find this. I'm just showing you how things are going. If we cross multiply, we get x is 8 times the square root of 3 over 2. And the 8 and the 2 reduce, and you get 4, right? 4 times the square root of 3. That's what Maureen said it was, right? Like this, the shortest side times the square root of 3. You could use SOHCAHTOA, you could use any way to find that last side. I was just pointing out law of sines works on any triangle. A 30, 60, 90 right triangle is half of an equilateral triangle. If you know the hypotenuse, then you know the shortest side because they're related. The shortest side is always half the longest side. And the way you find the third side is you just take the shortest side and multiply it by the square root of 3. Easy to do. So I've got 45, 45, 90, 30, 60, 90 right triangles. Why don't we do some problems? Why don't we make this 3 and find the other 2 sides? We'll make this 7 and find the other 2 sides. We'll make this 4 and the other 2 sides. Make this and the other 2 sides. I guess we need to show that it's a 45, 45, 90 right triangle. Sure. Now do this. Remember the ratio of the 3 sides. I'm using every color. The 3 sides of a 30, 60, or 45, 45, 90 right triangle. We know that the ratio of the 3 sides. If I use x, you could use n. X, x, and x radical 2. So the hypotenuse is the one with the radical on a 45, 45, 90 right triangle. You know, a 45, 45, 90 right triangle is just half of a square, right? So if you have a square there and you want to cut it in half, you draw the diagonal in, and then you have 2 45, 45, 90 right triangles. So it makes sense that these 2 legs of a 45, 45, 90 right triangle are equal because they're 2 sides of a square. And that side that you draw in there, you know, to cut the square in half is the one with the radical, because that's the weird one. And it's the same way with a 30, 60, 90 right triangle. But the ratio of the 3 sides of a 30, 60, 90 right triangle are 1x, 2x for the hypotenuse, and x times the square root of 3 for that extra side. Because a 30, 60, 90 right triangle is half of an equilateral triangle, right? An equilateral triangle, this is an equal, or a regular triangle, right? 3 sides, all the sides are equal, and all the angles are equal. This is a regular, the square is a regular quadrilateral, right? They're kind of like the same thing. This is half of a regular quadrilateral. All the angles are congruent, all the sides are congruent. This is called a square. And this is half of an equilateral triangle or a regular triangle. All the sides are congruent and all the angles are congruent. And that line that you draw to cut it in half, that's the one with the radical. Right? The line you draw to cut it in half, that's the one with the radical. Like if you're cutting a square in half, you can do it this way, and then you won't have any triangles to work with. Like the only way you cut a square in half to make triangles is to use a diagonal. You can't cut an equilateral triangle in half. The only way to do that is to draw an altitude to the opposite side, and the altitude would divide it into 2 equal 30, 60, 90 right triangles. And that extra line that you draw to cut it in half, that's the one with the radical. You know, the radical that you use on a 45, 45, 90 right triangle is the square root of 2, because there are 2 different lengths that you use for this triangle, right? There's the 2 legs, they have the same length, and the hypotenuse that is a different length, and you use a radical 2 with that one. With a 30, 60, 90 right triangle, there are 3 different lengths. The shortest side is half of the hypotenuse, the longest side, and then that extra line that you draw to make it two 30, 60, 90 right triangles. That's one, the radical. And the radical it uses the square root of 3. So tell me out loud, right? Say this with your voice. What is the length of this side? 3, right? Because it's the other leg. What's the length of the hypotenuse?
3 square root of 2.
3 square root of 2. That's simple, right? You don't have to do much thinking there. Right? So if you have one of the legs, it's easy to find the other two sides. The other leg's the same. The hypotenuse, you just multiply by the square root of 2. That's the way it is for every triangle. If this is 7, that'd be 7, 7 square root of 2. This is 12, that'd be 12, 12 square root of 2. It's always that way. 30, 60, 90 right triangle. There's a little bit more to know, but not that much. The hypotenuse is always twice as long as the shortest side. So if this side is 4, what's the length of the hypotenuse? 8. Well, you can double the number, or have a number if you get the hypotenuse. That's easy to do. And then the tricky part is to find this side. It's just the shortest side times the square root of 3. So what is the length of this side?
4 square root
4 square root of 3. Not too hard. But where things get difficult is when you get that extra line, like the radical line. Because the ratio of the 3 sides of a 45, 45, 90 degree triangle is x square root of 2. So if you've got, like this side, if 7 equals some number times the square root of 2, like what number times the square root of 2 is 7?
7 is,
What number times the square root of 2 is 7?
7 over square root of 2.
Yeah. 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 That makes sense. 7 equals 7 over the square root of 2 times the square root of 2. Square root of 2's cancel, it equals 7. That's the length of this side we're missing. 7 over the square root of 2. But you can't like leave the radical in the denominator, right? So you multiply the top and the bottom by the square root of 2 and get the answer. The length of that side we're missing is 7 square root of 2 over 2. Notice this 7 over 2. 7 over 2 is half of 7. Like if you want to see like the trick is, you just take half of this number, multiply by the square root of 2, and you got it. It's always that way. Like if this side is 5, no, it's not going to be 5 because that's not as easy to cut in half. If this side is 10, what's the length of one of the legs?
5.
Half of 10, 5 times the square root of 2. Like, that's all you have to do. But it's always that way. Like, these are easy problems. If you get this one, these are the same, multiplied by the square root of 2. Like, say we started with this. Say we started with this. 5 radical 2. We know this is 5 radical 2. And then to find this one, you just take your 5 radical 2 and multiply it by the square root of 2. What's the square root of 2 times the square root of 2? 2 times 5. 10. These problems practically do themselves. Okay. 30, 60, 90, it's not more difficult. Like say we got this is 10. So we're trying to figure out what number do you multiply by the square root of 3 to get 10. And I want my last fraction. What number do you multiply by the square root of 3 to get 10? Say it. 10 over the square root of 3, right, 10 over the square root of 3. That's the shortest side. 10 over the square root of 3, but you can't leave the radical in the denominator. So what you do is 10 over the square root of 3. You multiply the top and the bottom by the square root of 3, and you get 10 square root of 3 over 3. Now look, 10 over 3, that's just 1/3 of 10. Just divide this number by 10, multiply by the square root of 3, and you have the answer every time. It's just like this one. Divide it by 2, multiply it by, divide it by 2, 5 multiplied by the square root of 2, and that's the side you're missing. Right? So if you get the weird side with a weird number on these, just take 1/3 of it. If it doesn't divide by 3, just put 10/3 times the square root of 3. And that's the length of the shortest side. So it's 10 radical 3 over 3. How do you double this? Yeah.
20 radical 3?
Yeah, you just double the top, double this number. It's 2 times 10, which is 20 square root of 3 over 3. Like even the hardest kind of problem is not that hard. Okay? Are you buying this? Okay, because I'm kind of lying. Like 80% of the problems, you know, if you see these on the ACT, they're going to be, oh, this side's 3, find the other 2 sides. They really will be. What's this side? Say it.
3.
3. And what's this side?
3 square root of 2.
3 square root of 2. Right? The ratio of the 3 sides of the 45, 45, 90 is easy to remember. It's just, like if you can remember 1, 2, pretty much got it. I'm pretty sure you were taught that when you were 2. Right? 1 square root of 2. Easiest thing. So what if the hypotenuse is the square root of 10? Like how do you take half of that and multiply by that? Like, it's a little bit different. But remember, this is x, the shortest side, times the square root of 2. What do you multiply by the square root of 2 to get the square root of 10? Yeah?
Square root of 10 over square root of 2.
Which is what?
Which is square root of 10 square root of 2 square root of 20
Ooh, a lot of stuff.
2.
Let's look at this. Square root of 10 divided by the square root of 2. That's the square root of 10 over 2.
Which is 5 over 1.
Square root
of 5.
of 5. Remember, you're looking for the number. What do you multiply by the square root of 2 to get the square root of 10? That's just the square root of 5. So say you're looking at this, I'm like, I couldn't do that. I couldn't think like that. It doesn't matter. You don't have to think like that. Let's look at this 30, 60, 90 right triangle. Remember the ratio of the 3 sides. Are easy to remember. As easy to remember as 1, 2, 3. Like, you can remember 1, 2, 3. Right? X, 1x. 2x, you do have to remember that 2 is bigger than the square root of 3. X square root of 3. Say we get something weird for the third side, like square root of 7. That's weird. Like, what do you multiply by the square root of 3 to get the square root of 7? Like, oh no. You can still solve, this is an equation. If this x radical 3 equals the square root of 7, just write out the equation. X radical 3 equals the square root of 7. Like x radical 3 equals the square root of 7. How would you solve for x? Divide by the square root of 3. X equals, look, how do you simplify this? Multiply the top and the bottom by the square root of 3. And you get square, well on the bottom you get 3. On the top you get the square root of 7 times the square root of 3. That's just the square root of 21. It's really the same thing. It's really the same thing. We just take a third of this number, square root of 7 divided by 3, and multiply it by the square root of 3. Square root of 7 divided by 3 times the square root of 3. You get the square root of 21 over 3. That's what the length of this is. Oops. Should I put this? How do you double it?
2
So
square.
yeah, you just multiply by 2. 2 square root of 21 over 3. And those are the 3 sides. Alright. I don't have enough room to do these problems here. Okay. Let's start here again. I'm giving the hardest possible problems you can get on these. Man, that could be easy. Try these 4. Remember the ratio of the 3 sides. 30, 60, 90 right in front of it. 1, 2, square root of 3. Put the square root of 3 on the medium-sized side. The ratio of the 3 sides of a 45, 45, 90 is easier. 1, 1 is always the same. X square root of 2. Let's get going. Let's see what we have. Who's lucky today? Oh no, I don't even have a CD jar. Alright, it doesn't matter. I don't think you're in the right spots. I'll just choose your random number. I'll save it for now. I'll get it right later. Avery, what you got? That's correct. Half of this number times the square root of 2. If it's this number's 3, then it's 3 halves square root of 2. Easiest thing ever. So x times the square root of 2, you say square root of 3. Obviously correct. Right? If you don't know, set this equation out. X square root of 2 equals the square root of 6 divided by the square root of 2. X is square root of 3. If you have two radicals, you can divide them. Right? If they're under the same radical, you can just divide them. Nice. Max?
The hypotenuse is
We're going to go with the shorter side first,
6.
and then double it. To find the hypotenuse.
What did you say?
We're going to find the shortest side first. Because this side is the shortest side times the square root of 3.
So
So we have some number. Ooh,
4 square root of
4 square root of 3 is correct. It's a third of 12. 4 times the square root of 3. Works every time. What's the hypotenuse?
8 square root of 3.
Double 4 square root of 3 and you get 8 square root of 3. Wyatt?
The shortest side is square root of 2.
Square root of 2. Right? This is x square root of 3. So x square root of 3 equals the square root of 6. Just divide by the square root of 3. X is the square root of 2. What about the hypotenuse?
2.
Not 2. The way you get the hypotenuse from the shortest side is double it.
So it's
You like square root of 2 did.
yeah,
It's fun to say, we should try that.
2 square root of
2 square root of 2, yeah, just multiply it by 2. 2 square root of 2. Good. How are you guys doing? 30, 60, 90, 45, 45, 90 right triangles. Does that make, it needs to make logical sense. If you need to see a 30, 60, 90 right triangle is half of a 60, 60, 60 triangle. You need to see a 45, 45, 90 right triangle is half of a square, right? It makes what? No, there's more. There's more, right? There we go. Solve the triangle. You know what that means? That means we have to find the measure of angle A, the measure of angle B, the measure of angle C, and the length of side A, length of side B, length of side C. Actually, you know C is 90 degrees. Since A is 28 degrees, we know this B is 62 degrees. The length of the three sides, B is 15. How do you find the other two sides? Yeah.
Sine 62 over 15 equals sine 28 over 8.
So you want to use the law of sines? Should never shoot you. That's good. Yeah, you can use the law of sines. It'll work. Sine of 62 over 15 equals the sine of 90 over C. Or the sine of 28 over A. Like you can find both of them that way and it'll work. You'll be right. But let's use SOHCAHTOA. Probably what I need to be teaching. So, but it's not bad to always understand that the law of sines works. It is not bad to understand that. But if we're going to look for A, we're working with this angle. This is the side that's opposite, so we're going to have to use opposite and adjacent, which is what trig function? that uses opposite and adjacent. Tangent, sorry, hold it on. Tangent of this angle 28 equals opposite A, which is what we're looking for, over the adjacent 15. And just cross multiply A is whatever the tangent to 28 times 15 is. Make sure your, I'm not gonna use mine. Make sure your calculator is in grading mode. Not grading mode, degree mode, sorry, that's my calculator, calculus. Degree mode. 15 tangent of 28. What is it? 7.976, round to the nearest thousand. Then you could use the Pythagorean theorem to find C, or you can just use sine to find C. Because the sine of 28 is the fraction opposite, which is what we just found. No, we could use cosine actually. Adjacent, which is 15 over C. This one's a little bit more work because when you solve for C, cross multiply, you get C times the cosine of 28 equals 15. And you divide by the cosine of 28 to solve for C. And 16.989. Does it say around? Does it any particular? No. Okay. Solving a triangle. What time am I got? Like right now? Okay, let me give you this worksheet. Am I done here or is it still rocking?